and the old style, conventional style of ARP spoofing attack. Okay, one can, no matter what, no matter if you are using a WPA Too network, I can always use ARP spoofing attack. I can always launch ARP attack to do man in the middle. So in this old style ARP spoofing attack, your packet first goes to access point. And after that, access point decides and forwards those packets to wired segment of the LAN or wireless segment of the LAN, which means the security systems present on that network, wired IDS or IPS or switches, are going to see that packet, which means the footprint of the attack is available on the wire, and in any wired security systems which are capable of detecting ARP spoofing attack are going to capture that packet and detect this attack. Okay? But then when attacker is using this stealth mode attack, packets are directly sent by one malicious user to other Wi-Fi users in that network. Packets are never going to access point, and it is never reaching to wired segment of the LAN. Right? Which means the footprint of attack is limited to the air. Which means most of the wired IDS IPS systems will not detect this, because packet is not hitting the wired segment of the LAN. So without getting detected, attacker can do man in the middle attack and steal private information of other Wi-Fi users in a WPA Too network. Okay? So this is one example of GTK exploit or Hole 196 exploit. I'm going to present here the second exploit. And it's all about, changing the payload, what kind of payload you are encapsulating in that broadcast frame. So this time, attacker is going to use unicast IP payload inside that packet to basically launch IP level targeted attack. So for example, if frame is at layer 2, frame is broadcast, but I can always use IP layer 3 unicast frame inside that. And one example could be, port scanning. If I am going to use a payload which is used for port scanning, then my packets will actually reach to the victim, and victim will respond to that packet, which means I can do port scanning and I can find out whether that Wi-Fi user is vulnerable or not, which can further be exploited. So just think what else is possible. If I know that this payload is going to cause some buffer overflow, then I can inject that packet. Right? I can also inject malware. So a frame is available in which attacker can encapsulate payload of his choice and cause serious damage to other Wi-Fi users. This is the second example of GTK exploit. The third example of GTK exploit is related to the replay detection in WPA 2. There is something called replay detection in WPA 2. So all encrypted data frames have there is a field called packet number, which is a 48-byte number. And this number is going to be present in all encrypted data frames. And this number is used to detect whether a frame is replayed or not. And how that replay detection works? When client connects to access point informs that client that this is the last consumed packet number, so you should use this number for replay detection. So for example, last consumed packet number was 700. Client is going to cache that number, save that number, and after that client is expecting data frame having packet number greater than 700. So for example, if I am replaying a packet which I have captured at the time when packet number was 600, and if I am replaying that packet will not be accepted, because client will find that the packet number is less than the last successfully received packet, which was 700. When access point sends packet, it will send with 701, because that is part of its traffic stream. It has already sent 700, so next packet will be 701, 702, and so on. So when access point sends packet with 701, client is going to accept that packet, and once the packet is successfully decrypted, client is going to update its locally cached packet number. So now the packet number becomes 701. And that 701 will be used to detect replayed frames. So attacker is going to exploit this replay detection logic. Here what attacker is doing, he is injecting a very large packet number, arbitrarily generated number, because it is a 48-bit number, right? So let's take this example in which client, the last successfully received packet number was 780. At this point, attacker is injecting a packet because attacker knows the GTK. He can create its broadcast frame. He can put any number of his choice. So he's going to put a number, let's say 9,999, 949s, okay? Client is going to accept that packet because at the time of replay detection check, it finds that packet number is greater than the last successfully received packet number, which was 780. So the client is going to update its locally saved packet number, and the local packet number becomes 9,999. Access point has no idea about this change which has happened on the client device. So access point will send broadcast packet as per its own traffic stream. So the last packet which sent by access point was 780. So next time it will send 781, 782, 783, and so on. But let's see what is happening at the client device. Client device finds that the numbers are too less to the locally saved packet number. The last saved packet number was 9,000 and I am getting 781, which means somebody is replaying packet. So client device is going to drop all the broadcast packet whose packet number is less than its locally cached packet number. Now imagine the implication of this. All Wi-Fi client devices who have successfully received attacker injected high packet number will start dropping all the broadcast packet coming from access point, which means the protocol which works on broadcast packet will not work, right? Two clients will not be able to communicate with each other because they will not be able to resolve ARP. So attacker, by exploiting this replay detection logic, he is causing denial of service attack in downlink direction, and which can break few protocols. So this was the third example of exploit of hole 196 or GTK vulnerability. Now I will talk about the POC code that was written to exploit GTK. And I have used two open source software. One is WPA supplicant software, and I have used it. There was no modification done, so it was used as it is. And then I have used open source driver, madwifi. And the main modification was done in the driver part of the madwifi. So before we actually see what kind of modification was done, let me quickly present the .11 frame here. When a client sends a packet to access point, it is called 2DS frame, okay? From client to access point, uplink packet. And when access point sends a packet to client, it is called from DS packet, or it is a kind of downlink packet. And there is a field present in the frame which indicates about the direction of frame, whether it's going from client to access point or it is coming from access point to client, okay? But if you notice, there is not much difference between 2DS frame and from DS frame. If you do a cyclic shift, 2DS frame will become from DS frame. You move address 3 to address 1, address 1 to address 2, and address 2 to address 3, it will become from DS frame, right? And this requires 3 lines of code to do that, and 1 line of code to change 2DS flag to from DS flag. So in 4 line of code, you can actually convert 2DS packet into 4DS packet, from DS packet. And then you need to select a right key to encrypt that packet, because client always use unicast data traffic, so it always use unicast key. So 6 lines of code were added to choose the right key. So it's just about selection, in which data structure what kind of key is stored, right? So in just 10 lines of code, it was possible to exploit the GTK vulnerability. So now I will do a demo of man-in-the-middle attack in which GTK vulnerability will be exploited. And after that, I will talk about the countermeasures. So in this example, the demo that I am going to do now, I'll be using 2 Wi-Fi client devices. One client device is going to be the same laptop which I am using for presentation. And then I have one more laptop here, which is running backtrack. And I'm going to use one of the tools available for launching man-in-the-middle attack. There are a lot of tools available using which one can launch MITM. So, for example, these are the tools, very popular tools which are used to launch man-in-the-middle attack. So I'm going to use one of the tools. So the only modification, the only soft code changes that was done was in madwifi driver. Everything is available open source. I have set up one access point here, and you can see the SSID of that access point is corporate Wi-Fi. And if you go, you will see that this is a WPA 2 configured. This is a WPA 2 access point. Okay. So I'm going to access my attacker machine with the help of VNC software so that you can also see what's going on the attacker machine. Okay, so my machine is accessible, so we can access this. So this is the backtrack running machine which I'm going to use to launch attack. Okay, perfect.